Well, let's look at some loops. In this unit, we'll be working with loops, but I'll give a quick review. There are three main types of control structures. Of course, loop is happened to be one of them. We have sequential, selection, and repetition. And here's how they break down. The sequential is going through code one line at a time. Okay, so you see one line, you do the next line, and the next line, and so on, going down, top down. Selection have three. So selection is going to be if else, and switch. We'll hold off on the switch for the very last structure to look at in this unit. Repetition is what we're going to look at right now because we saw the if and the else if before. So we're going to look at these three, and I will not necessarily break them apart. I'm going to do all of them together. So what that gives us? That gives us 7 types of control structures. Either we're going line by line, or we're using any one of these 6. Okay, so 1, 2, 3, 4, 5, 6, or we're going line by line, and that's it. So if you think about computer science, it's basically 7 control structures, a 0 and a 1 for your bits, and you're pretty much done. You have the and or is how you connect these bits. You have a not, how you can flip a bit, and you control your code with these. And just that small set, we can create nice methods, nice classes, and sophisticated code just using this little small set of things here. So, which is pretty neat. Not much to remember here. And again, these are interchangeable, which means you could choose to use if or if else or switch. You got a lot of flexibility here. You could use while, do while, or for. You don't have to use all three, but I will be showing all three. So first off, let's talk about what a loop looks like. So first we have a counter-controlled loop. Let's call that a one type of loop. Okay. And we have another type of loop called a sentinel controlled loop. And I'll show you both of these. So counter control loop is when you're using some integer value and you're literally counting. So the questions to ask when creating a counter control loop, oh, by the way, this is the most common loop. Okay. It's the one you use most often. So you ask yourself, from where am I starting? Where's my starting point? What's the first value in my counter? Where am I ending? What's the last value in my counter to make this loop go? How am I getting there? Am I getting there by adding 1? Am I getting there by adding 2? Am I skipping over numbers? Am I going backwards, subtracting? How am I getting from the starting point to the ending point to guarantee that this loop will stop? Sentinel control loop is going to use an if statement to stop the loop. So some condition is going to happen and the loop is going to stop. And here's how all three of these loops look. The while loop looks like this. Again, just like if statement, there's a condition, and if it's true, we execute the code inside. If it's not true, while loop's finished. Same is true for do while, but look at how the do while looks. There's a do, then open curly brace, the block opens up and it closes. The only control structure with a semicolon to end it is the do while. All the others, no semicolon. Okay, so we have this condition in here. So the do while loop has this type of structure. The for loop has this structure. This is called the for header. Okay, and I prefer this loop. It's the one I use most often because it pretty much sums up this up here. Okay, where am I starting? This condition is where am I stopping, and this is how am I getting there. And they're all laid out right here. So I'm going to have some examples in a while, and we're going to walk through them. I'm going to write the same example 3 ways, just so you can see. So here is something here down here. I have the differences between a while loop and a do while loop. A while loop has the condition first, and the do while loop has the condition last. You can see. There's also a do while loop running at least once, right? So the do while loop is going to run and then check the condition to see if it should run it again. Okay, so we have some semicolon, a semicolon here, no semicolon up there. So there's some differences between these two. This do while loop, not often used, but it's normally used in a game. If you're making a video game, it's a do while loop. And the idea is, do you want to play the game? The answer is going to be yes, because there's nothing that's stopping the game from playing, right? This is called a game loop. You do it, you play the game runs, and the person gets to play. And the condition is now, are you going to play again? So the idea here is it's going to run this, and then it's going to check to see if you should do it again. Here, though, it's going to check first. So this might not run, because if this is false, skips it. Okay, even if this is false the first time around, it's going to do it at least once, because there's nothing stopping it from getting in. The for loop is my favorite one, like I just said, because everything here is controlled, nicely neatly packed away in a header here. And it's the three statements. Okay, where am I starting? Where am I ending? That's my condition. Always, condition is to end this thing. We need to go towards some ending point. And increment or decrement, either going forward, plus plus, or minus minus. Now I want to do some examples down here, and these examples are horizontally print all integers starting at 1 and stopping at 10, vertically print all even integers, even, between 21 and 41, horizontally print all integers starting at 10 and stopping at 1, so we're going backwards. Vertically print all multiples of 3 starting at 3 and ending at 20, and horizontally print all characters in the string lemon, backwards. Okay, so I'm going to take this off. It sounds a little weird here. Horizontally print backwards all characters in the string. Okay. Before I start writing these, I want to show you something, and I'm just going to write a while loop here. Now you may think that this is a little weird, but I have to show you this. Now I said a condition is here, and instead of me writing in a condition like x less than something or y greater than something or some kind of condition, I wrote true. And the reason why I'm writing true here is because I want to show you an infinite loop. The concept here is this loop will run forever. Now, an infinite loop is very, very good to write when you're doing it with games, right? Because the idea behind a game is you don't want them to put it down. You want them to keep playing and playing and playing, and they get all hooked, and then you have in-app purchases and you make money. The idea is to keep it going. And there are times when things need to run as forever too, like a printer that does its spooling and stuff like that goes on forever. It could, do I have anything to print? Do I have anything to print? Do I have anything to print? Yes, you have something to print. Print it. Do I have anything to print? Keeps asking that over and over again. So sometimes this is good. But I'm going to say we are going to avoid this. Avoid it like the plague. Avoid this. Don't have your condition somehow always true. The opposite is true as well. Don't have it always false. It needs to be true sometimes, false sometimes. Okay? So if it's always true, it's going to run forever. I'm going to run this. See? Let me slide this over. You could see the hello just printing forever. Doesn't matter how good you are at writing loops, doesn't matter how long you've been writing code, this is very common. Many times you'll write yourself an infinite loop. Now, when that happens, your app freezes. Okay? It doesn't crash, it freezes. Which means whatever is that's supposed to come after this will not happen, because it's going to get stuck in a loop. The only way you can stop this is by either quitting the whole of Eclipse, or looking over here, you're going to see a red button right here. This is an indicator that tells you, you see what it says? It says terminate. It says terminate, stop the loop. So this little red button here is what you're going to use anytime you're writing code from here on out, because now we're getting into the big leagues. You're going to have to stop any infinite loop. Now, how many of these hellos printed? A lot. Okay, the computer works really fast in milliseconds, so that's a lot of hellos. Okay, so let me put a little note up here. Do not do this. Okay, so I'm gonna go ahead now and comment this out because I don't want this. It's just an illustration for you to see. You don't want to be doing any infinite loop. Okay, so I'm gonna go ahead now and write these loops, and I'm gonna write them the three ways. Okay, so example one, we want to print horizontally. So I'm going to start off with an int called value, and it starts off at 1. You say, well, how do you know it's starting at 1? It said it. And it stops at 10. So while my value is less than 11. Whoa, we got to think about it. Okay, don't put a semicolon here. Do not do that. It's not a do while loop. Okay, so this is less than, so wait a minute, stopping at 10, less than 11, should it be less than 10? This is where we have to think. You have to think about where you're starting, where you're stopping. See, less than 10 means 9 will run, but 10 won't. Let me say that again. 9 would run, but 10 won't. Like if I put 10 here, 10 is not less than 10. That'll be false, loops over. So if I want 10 to be included, I could do less than 11. Another way I could do this, I could say less than equal to 10. See why we were doing those Boolean things earlier? See those Boolean pieces, they need to come in here. So now I'm stopping at 10 by saying when you get to 10, do 10, but when value goes up one more to 11, stop it. Well, how am I getting there? Well, I'm getting there by adding 1. I'm going to show you 2 ways to do that. These are all things we did before, so they're all coming together here. Plus equal 1 means add 1 to the value, assign it back. Or plus plus, same thing as adding 1. The only thing I need left to do now is to print. So I'm going to go ahead and print system.out.print, not ln. I'm going to print the value, and I'm going to put a space, concatenation. Right? Since I put a string here, this is going to become a string, and it's going to print them all nicely. So I'm going to run this and watch it. That's with the while loop, see? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Nice and easy. Where am I starting? Where am I stopping? How am I getting there? I need to write the other one. That's the while loop. Let me do the do while loop. Same question. Do. So let me start over the value. Make sure the value goes back to being 1. And then I'm going to say do while I'm thinking about this, okay? Value less than equal to 10, semicolon. It's the only one with a semicolon. And I'm going to print it. All right, let me just copy this. I need to type this again. And then I'm going to say value plus plus. Let's just run this again. Actually, you know what? Let me put a little print in between them. So system dot print. Put a little print in between, so we can put a little space in between there. So let's just see. Boom. See? Doesn't really matter if I did it with a while loop or do while loop. And again, when you get a question and you got to write a loop, you choose one. I'm showing all. You don't have to do all. Just pick one that you like. Starting, stopping. How am I getting there? Starting, stopping. How am I getting there? They're all over the place. I'm going to do it now with a for loop, and I'll show you why I like a for loop. So I put a little print in between these. So for, let me start the value over, okay? You know what? I'm gonna just go with the for. For int I equal to, so we're starting at 1. I less than or equal to 10. I'm stopping at 10. I plus plus. Now I'm gonna print I. See? This is why I like the for loop. Where am I starting? Where am I stopping? How am I getting there? Nicely wrapped up. in the for header in the same order. Okay. Now let's just see how. Let me run this, and we will see the three of them. Okay, they're all doing the same thing. It's nothing different here. So the other thing I want to do then is I want to see how this thing works. I want to do like a hand trace. How does it work? How does this work? Okay. So value starts off as 1. It comes here. It says, is 1 less than or equal to 10? True. Goes in, print a 1, print a space after it. The 1 prints as a string. Remember, concat. Then value plus plus. No value goes to 2. It hits the end of the while loop. It comes back and say it's 2. That's why it's a loop, because it keeps coming back. It's going to keep coming back until this condition ends it. So it comes back with a 2. Is 2 less than or equal to 10? Yes, it is. Print the 2, print the space, add 1. Now it's a 3. Come back. Is 3 less than or equal to 10? Yes, it is. Print the 3, put a space, add 1. Now it's a 4. Come back. It's going to keep doing that. Eventually it gets to 9. It prints the 9, it adds 1, it goes up. It says 10 less than or equal to 10. Yes, that's true. Print the 10, put a space, add 1, come back. Is 11 less than or equal to... No. Break the loop. Where am I starting? Where am I stopping? How am I getting there? Now the same is true here. Starting at 1, it goes in. There's nothing to stop it. It prints the 1, put a space, add 1 on, it comes here. Is 2 less than or equal to 10? Yes, it is. Come back, print the 2, add a 1, now it's a 3, and it's going to keep doing that, and we get the same answer. Come down here, starts at 1. This gets a little confusing sometimes. People think that this goes straight across. It does not. It behaves just like these two loops. They're interchangeable. You could use this and never use these ever. You could write all your code and always use this. You could write all your code and always use this. You could write all your code and always use this. There's no reason to be using. I'm only showing you all three. You pick the one you like. I like this one. But it behaves just like the others. It's starting at 1, so it's going to be 1. It's going to say, is 1 less than or equal to 10? Yes. Comes in here, prints a 1, prints a space, and come back here, adds 1, and come back. And then say, is 2 less than or equal to 10? Prints a 2, space, come back. So it behaves just like this and this, except the header is compact. So it's start, check, do, increment. This is called an increment, adding 1. Comes back, check, do, increment, comes back, and like that. So that's how we do all three of these. Those are counter controlled because it was being controlled by the value, or in this case, I. For for loop, we usually use I in here. Now the other thing that I'm going to do is a sentinel loop. Okay, remember I showed you that sentinel loop, this one. Sentinel controlled. I'm going to do the same thing, but sentinel controlled. Okay, so here we go. So I'm going to say the int sentinel is -1. Okay, actually, you know what? Let me make a string just to show you. The sentinel, just some value that is going to stop this loop. So I'm going to say while the sentinel is an A. Now I know in this point you're saying, wait a minute, shouldn't you use dot equals? But I use a string later, or else I could get away with it. But even if I want to be really careful, like I said, dot equals. I could say dot equals. I mean, this is going to work as well. So if that is, and sentinel not spelled right, if that is equal to A, print this. Okay, I'm going to copy, paste. I'm going to print the value. I'm going to start the value back at 1. Okay, so if it's equal to A, print it. Okay, so it's going to keep printing the value. Now I need to update the value. Remember, we need to get there somehow. So I could write it with an if statement. That's what I said. The sentinel value should be written with an if statement. Okay, so only when it's A, it prints, so or goes in. So I could say if the value is less than or equal to 10, I want you to do two things. I want you to print it, then I want you to increment it. Otherwise, I want to change the sentinel value to B. See, this is a sentinel controlled loop. I'm not controlling this loop with the value, I'm controlling it with this. So it comes in, it says, is it an A? Yes, it is. So it goes in, it prints the value 1, puts a space, add 1 to it. It skips the else. Remember, double selection, comes back up, says, is it still an A? It is. Is the value less than 10? Print it. The minute the value is not less than 10, though, it changes it to a B. When it comes back, it's not an A anymore. Boom. Actually, I'll put a little print in between this so we could see them all next to each other. See? Same thing. Hey, you may say this is a little convoluted, complicated way to do it. True, but sometimes you don't know where you're ending. Your ending might depend on a condition. Okay? And in that case, a sentinel control wins. Because if you're running a loop and you don't know how many times it's going to run, let's see this one, we know it's going to run 10 times. So this is unnecessary. But let's say sometimes you're running a loop and you don't know when it's going to stop running. It may run 10 times, maybe 50 times, maybe 80 times, maybe run no times. You don't know. If you don't know, sentinel is good. All you do know is when something goes wrong, stop it. Okay, and I'm using these vague terms because it could be anything. If something goes wrong, stop it. That's a sentinel loop. You want it to keep running until something goes wrong or until this thing is reached or whatever it is. Then you can use a sentinel loop. So even though I show you all three here, I'm not going to necessarily do all the rest with a while loop or a do while loop or for loop. I'm going to pick one that I like and I'm just going to use that, and that's what we're going to do. Next example, we're going to vertically print all the even integers, okay? I'm going to write this with a for loop. For int I equal to, so it's between 22 and 41. So I'm going to start at 22. I less than 41 because it's between. And I plus equal to system dot out dot print ln because it's even I. See? Starting at 22, it says between, so I went to the next one, 22, and it's even. And to get evens, I gotta add 2. I don't want to add a 1 like this, because if I did add 1, this would print 23. Don't want that. So I could skip it by adding 2 and just print all of them vertically. Let's see how that looks. There we go. 22 is here. Let me put a print so that everything lines up nicely. I should put prints between every example. So basically what I'm saying there is once you get, you know where you're starting and you get that idea of where to end, you got to think how to get there. Now let's say I wanted to get there by adding 1. Let's say I said I wanted to get there by adding 1. Well, I could use a selection. I could say if I mod 2 is 0. Let one sink in for a second. Mod means the remainder is 0. And if I divide by 2 and the remainder is 0, it's even. Now that's another way to do it. Same answer I get. I mean, if you could avoid using the if statement, you do it. And if you think that that's the only way to go about it, then you could do it that way. So I'm going to leave both here, plus equal to. So we could see both. So we don't have to do both. We only need one. But just so you know, another way. Okay. Coming down. No, you realize I just use a for loop here because that's one I like. If you like the while loop, you write it with a while loop. How would we? I'll put a card little one print here. How would we do this? Horizontally print all integers starting at 10 and stopping at 1. Well, here we go. For int I equal 10. Why? I'm starting at 10. Okay. So we got 10 and I must be greater than or equal to 1. That's when I want this to print. Because it can start at 10 and then I minus minus. I want to subtract 1. Start at 10, take 1 off, go to 9, 8, 7, 6, 5. Go all the way down till you get to 1. And we print. Now it's printing horizontally, so I don't want to print ln. Right? I want to print, then I want to do a space after, so we can get them all going across horizontally. Here we go, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Bingo. Okay, you could challenge yourself to write it a different way if you want. Let's go to this one. Vertically print all multiples of 3. So we want to go 3, 6, 9, right? We're going to 3 times table. We're going to start at 3. We're going to end at 20. So 4 int I equal to 3. I must be less than 20. I plus equal 3. If that's what you thought, you're right. Because I want to go 3, 6, 9. So I don't want to add 1. I don't want to add 1. And I got to be careful here. Oh, by the way, when you're doing a quiz, I'm going to ask you these questions on the quiz, just so you know. When you're doing a quiz and it says vertically print all multiples of 3 or something like that, if you're doing something like that, or some other example here, if you're writing your code and it says printed horizontally or printed vertically, you have to pay attention to this print. Okay, that's why we did it early on. We're not going to just forget it. So this is a horizontal print, so I want to do a vertical print. Don't need the space after it then. It's going to be all falling down. So here we go. Let's see if we see those 3's. Okay, so 3, 6, 9, 12. Perfect. And for the last one, we're going to mix in a little bit of strings. Okay, in the next section, we will do a little bit more algorithms, more heavily written algorithms. In terms of complexity, we're going to go a little bit more complex and write something that's a little bit more meaty. We're going to include strings, and we're going to include all the stuff that we did before: character at, index of, substring. Here we go. I want to write this guy backwards. Okay, so for int I equal to lemon dot length. Actually, you know what? Before I do that, let me go ahead and find the length of lemon. Lemon dot length. So I just found the length of lemon. I stored it. So I am going to start from the back. Int I equal to length minus 1. I must be greater than or equal to 0. I minus minus. Since I'm horizontally printing, I'm going to print I position of lemon. So lemon dot character at the position I. So let's see how this works. Lemon has 1, 2, 3, 4, 5 letters, so the length is 5. I am not starting at 5 though, because we label them starting from 0. In computers, we always start at 0. So 0, 1, 2, 3, 4. The guy in the 4th spot is the n. That's why I'm starting at the 4th spot. Realize I'm doing length minus 1. So it doesn't really matter what word this is. This code, as long as we have the word here, if we use a variable, for example, the variable is going to take the place of where lemon is. And this code works for all strings. So we start at 4. And we're going up until we get to 0, which is the L. Let's run that. See? There it is down here. Lemon backwards. Now, you're looking at this and you say, wait a minute, is there another way to do this? And the answer is absolutely yes. Let's try doing this with a substring. How about doing that with a substring, which is part of the string? So if you're going to write lemon with a substring, first thing we want to do is change this character add to dot substring. Okay, and the substring has where we're starting and where we're ending. Okay, so we want to put the end here to be I, and we want the guy up here to be I minus 1, right? Because we're going backwards. Now, the thing about this is that we have to be really careful, because if we run this, we could run into some trouble. Let's run this and see what we get. We have to be careful with the edge of this thing. Okay, so let's look at it. Ooh, we got an error. We got an error. It's saying index is out of bounds, -1. Okay. So something is wrong. I mean, this is the right idea, but something is wrong about where we are stopping and starting, right? Because we know we need to be subtracting 1. So let's see if we do greater than 0, how that works out. Okay. So we got O M E L. So we don't have the N. Okay. So it looks like that greater than or equal to 0 made a crash. And yeah, because we're going backwards, and when we get to equal to 0, we're going to take 1 off. So we go to -1. Oops, that's not, there's no -1. It looks like we're missing the first guy though. Okay. So obviously that means I need to start at length. Now remember, substring has lines between, so this will be 0, 1, 2, 3, 4, 5. Obviously that's where we missed the end, because when you do substring, you want to go at length, but if you're doing character, you want to start at length -1. You always want to go to length -1 when you're actually going towards the actual character. But with substring, it could be 1 off. So let's run that and see if that works. There we go. Perfect. This is with substrings, and this is with character. Two things we've seen before. Now, coming up in the next section, we will do a lot more of these, but we'll be doing a lot more complicated, more involved loops that can do some really neat stuff. Again, this is the loops. This is the start of it. We did all of them. Next, complicated, a little more complicated loops using strings, using characters, using all types of data types, doubles, ints, and so on. And then finally, we round off this section with some switch statements. Okay, that's the end of it for now.